All right, so what I want you to do now is go ahead and draw an electroscope. The electroscope has the pole and then has vanes at the bottom. The vanes are free to move and the pole is fixed. This is a continuous path of metal, and typically we have a flask that we put this in to protect the vanes down below and a little plug here, but that plug doesn't affect the movement of charge up and down the from the pole to the vanes or from the vanes to the pole. And so if we take a look at in a situation here, let's say we have an electroscope and we bring a balloon close and we want to draw what happens. One of the key things, and this may be the most important thing with electrostatics because it's so central to understanding and describing electrostatics. The key thing is that with electrons, the electrons can move from atom to atom, but positive charge can't move. The actual atoms can't move. And so if we bring this balloon close to the pole, what's going to happen is the electrons are going to run away out of the pole. There's still going to be some, electrons at the top for sure, right? Because, the atoms at the top are, can shed some of their electrons. They're going to keep some. But the electrons, a lot of those electrons are going to go to the atoms at the bottom, filling those empty spaces with the neutral atoms at the bottom. And the bottom will be negatively charged, the top will be positively charged. Now, as soon as you bring the balloon away, though, those negative charges are going to come back up because atoms do not want to be, not neutral, right? They want to be neutral. And so those electrons are going to come back to the top, leaving it, neutral again. So what I want you to do on this one, let's say we bring a glass rod towards a pole. I want you to pause the clip and draw what you think would happen as you bring a glass rod towards the pole of an electroscope. All right, so what you should see is that electrons rush to the top. And again, with the logic, the only thing that can move are electrons. If you said something like, oh, maybe some protons are going to go down to the bottom, that's backwards, right? They can't do that. Electrons are the only thing that moves in electrostatics. And so, the electrons are going to rush to the top. The bottom is going to be positively charged. And what does it mean that something is positively charged, right? It doesn't mean that it has more protons. It just means it has a lack of electrons, leaving the atoms positively charged. That's what that means, is that, the plus sign means that they're, representing atoms that are positively charged. Now, if we were to bring the balloon close to the pole and actually touch the pole, that's called charging by conduction. And so the first step we should be able to draw, right? We bring the balloon close, the electrons should run away. Now, if we actually touch the balloon to the electroscope, what will happen? Well, we know that the pole is positively charged. That means it has a lack of electrons. And so if it touches, even though the balloon's not a good conductor, some of those electrons will leave and come onto the pole, filling the empty spaces of the atoms up here. Now, these electrons are still down here, right? But now we have more electrons on here. So afterwards, the whole electroscope has more electrons than it did before. And therefore, electrons come onto the pole. Now the whole thing is negatively charged. And that means that the electroscope has more electrons than it did before. All right, so now I want you to try it with this one. Let's say we bring a glass rod, we bring it close, then we touch it, and then the afterward effect. So you're going to have 3 pictures, this one and then 2 more. Go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. Okay, so we bring it close. When we actually touch it, the electrons will come off and go onto the glass because these glass atoms have a lack of electrons. They'll pull some of those electrons off of the pole, and therefore that pole afterwards has a lack of electrons. The charge will distribute back to normal. Those electrons come off, but then, the whole electroscope will be positively charged because now it has a lack of electrons. In other words, there's more of the protons outnumber the electrons. All the atoms in the metal and it's positively charged. Okay, now charging by induction is another thing that is important to take a look at. And, conduction is touch, right? We talked about that in the thermal unit. Transfer by touch. In thermal, heat, that was by conduction. With electroscopes that we just saw here, that's the same thing. And so let's go ahead and draw a neutral sphere, and we're going to bring a balloon close to it. Now, if we do that, the charge is going to get as far away from that balloon as possible, leaving the other side positively charged. And so we bring it close, and the charge goes to one side. Now, induction is where we ground the object, and grounding means that you provide a pathway for an infinite number of electrons to come on or go off. In this case, we see someone touching the sphere, representing, a pool of electrons that can either come on or go off. In this case, because we have a balloon that's getting close to this glass rod, those electrons are going to have a path to run away. So the electrons run away. And as they do, and let's say we remove our finger, now there's less electrons on there. The whole thing is going to be positively charged. All right, so now let's take a look at charging by induction with glass. Let's say we have our neutral sphere and we bring a glass object close. What I want you to do is to draw the remaining pictures, the 3 remaining pictures. When we ground it, after we take our finger away, and then our hand away from grounding it, and then afterwards. And let's see if you can follow that logic. So go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. All right, so we bring it close, we provide a pathway, and in this case, we're providing a pathway for electrons to come on, because that positive object is going to attract negative charge and pull it on. And so now, the sphere is negatively charged, and that side of it is still going to be more negatively charged than the other, and the whole thing will become negatively charged as a result of charging by induction there.